Alright, so in this video we are going to be looking at rationalizing the denominator. The reason that I would need to rationalize the denominator is if I have a radical or an irrational number in the denominator. So a number that is the decimal is non-terminating, non-repeating. If that happens, like these examples on the screen, I would want to do something to get rid of that irrational or that radical number in the denominator. And so the goal of this section, you can see that I've highlighted, is to get one in which there are no radicals in the denominator. So here are our steps. The steps are pretty straightforward in terms of the square root. The cubed root is going to look a little bit different, but we'll see some of those later on in this example, in the video. So example 1, I have the square root of 14 divided by the square root of 7. And so those steps up above say that I can multiply top and bottom by the denominator. So that's going to be my first step in rationalizing the denominator. So I'm going to multiply top and bottom by the square root of 7. On the top, I can write this as the square root of 14 times 7, which gives me the square root of 98. And then on the bottom, I can write that as the square root of 7 times 7, or 49. Let's write that as 7 times 7, and then the square root of 49. So the property I used said that the square root of A times the square root of B, I can stick both of those under one square root. That was a property we saw earlier in the sections in this chapter. Now I'm going to simplify. So this thing I can simplify using my factor tree because it's not a perfect square. So I'm going to just work off to the side and do 98. Well, two numbers that multiply 98, I have 7 and 14. And then two numbers that multiply to 14, 7 and 2. Which means that the square root of 98 is the same thing as 7 square root 2 over the square root of 49 is 7. It's a perfect square. And so for that, I can replace where there was a 49 with just a where there was a square root of 49 with a 7. Now I have 7 square root 2 divided by 7. And so I can actually cancel those two 7s, and I'm left with the square root of 2. And so there's a shortcut to this one that would work. It doesn't always work on problems, but in this one it does work. We also had a property that says the square root of A over the square root of B is the square root of A divided by B. So what this says is you can combine, quote unquote, for multiplication and division. So my shortcut could have been that the square root of 14 over the square root of 7 was the same thing as the square root of 14 divided by 7, or 2. Now that doesn't always work. This method always works, which is what I'm going to continue in the videos. But if the two numbers do simplify in terms of like if you were to write them as a fraction, you certainly can go through this shortcut. All right, let's look at the next one. Okay, so I've got the square root of 40 divided by the square root of 5. And so I could do the shortcut on this one, but I'm going to go kind of the long way. I'm going to multiply top and bottom by the denominator. Square root 5, square root 5. Which is going to give me the square root of 140 times 5 on top, or the square root of 700. On the bottom, I'm going to have the square root of 5 times the square root of 5, or the square root of 25, which gives me just 5. Another shortcut would be the square root of something times the square root of the same thing is going to always equal that thing. And so that's a shortcut that we're kind of using right here, that the square root of 5 times the square root of 5, because those are the same and they're being multiplied, the square roots undo each other. And we saw why in this example. All right, so now I need to go through and I need to simplify using my factor tree this 700. So I'm going to work off to the side and do my factor tree. 700, well, I have two already, 140 and 5. 140 is going to be 14 and 10. 14 is going to be 7 and 2. 10 is going to be 5 and 2. And then, of course, the 5 is done. So my pairs, I've got a pair of 2s and a pair of 5s. So coming out, I've got 1, 2, and 1, 5, or 10. And then on the inside, I've got a 7 left over. And then divided by that 5, I can reduce these. And so I can divide top and bottom by 5 and get 2 over 1. So I've got 2 square root 7 over 1, and I don't need to write that 1 on the denominator, and so my final answer would be 2 square root 7. All right, I'm going to do another video with the cubed roots, so for now we're just going to focus on square roots. And so example 2, y divided by the square root of 3 plus 3 square root 5. So when we've got multiple things in the denominator, we are going to multiply top and bottom by what's called the conjugate. The conjugate means that you are just going to change the middle sign. So if the middle sign was positive, you're going to make it negative. If the middle sign was negative, you'll make it positive. So in this example, the conjugate is going to be square root 3 minus 3 square root 5. And I'm going to multiply top and bottom by the conjugate. And so now this is going to turn into a multiplying example. So I'm going to work off to the side. I'm going to do the whole top. So I'm going to work the top over here. So the top says y times square root 3 minus 3 square root 5. I'm going to distribute that and get y square root 3. Distribute that. Okay, so I distributed the y. That's going to be my top. The bottom, the bottom I'm going to work over here. This one, because I've got 2 sets of parentheses, I'm going to FOIL. Okay, so I'm going to FOIL this. First, square root 3 times square root 3. Outer square root 3 times negative 3 square root 5. Inner square root 3 times 3 square root 5. And last, 3 square root 5 times negative 3 square root 5. Okay, so here are all first, outer, inner, last. All right, now I'm going to go through and simplify. The square root of 3 times the square root of 3 is that shortcut we saw. That is 3. Square root of 3 times negative 3 square root 5. I'm going to move that negative 3 forward, and then I'm going to multiply the square root of 3 times the square root of 5 to give me 3 times 5, the square root of 15. I'm going to do the same thing with the next one. Move that 3 forward because it's outside of the radical, and then the square root of 3 times the square root of 5 is going to give me the square root of 15. And then the last one, I've got 3 times negative 3, or negative 9, and then the square root of 5 times the square root of 5 is just going to be 5. So I've got negative 45 there. And then because the conjugate is done in such a way the outer and inner is always going to cancel. So if you do the conjugate correct, those will always cancel because they're the same, but opposite sign. So I have negative 3 square root 15, positive 3 square root 15. So those would actually cancel. They undo each other. So I'm left with here 3 minus 45 is going to give me negative 42. So that's going to be my denominator. This over here is going to be my numerator. So I'm going to go in and fill those two in. And so I've got y square root 3 minus 3y square root 5 all over negative 42. So I can't simplify in terms of, I can't cancel anything with all of these, but I don't want to write the negative sign down at the bottom. What they're going to want me to do is take that negative and write it up top. But if I write it up top, I'm going to have to distribute to the whole thing. And so how my final answer is going to look is negative y square root 3 plus 3y square root 5 all over 42. So what I did was I distributed that negative to change both signs on top. And then that would be your final answer.